Have you ever been in a situation where you are trying to write a SQL query and someone says to you, why don't you just use a Windows function? And you're like, wait, a Windows what? Is that like opening up a window in my database? Window functions sound intimidating at first, and I'm going to be very honest with you. But once you actually understand them, they become one of the most powerful tools you can use in SQL. They let you do things that normally require really messy subqueries, like calculating rankings, running totals, moving averages, or comparing a row to the row before it, but in a much cleaner, more efficient way. So today, we're going to be breaking Windows function down from the ground up. We'll look at what Windows functions are, why they exist, when you would really use them in real life application, and finally, because this is a data channel, we're going to be doing some real life demo, practice some examples, and even set up a table to do that. But first, let's talk about why we even need Windows function. What is the problem statement? All right, let's imagine a simple case. You're working with a sales database and your manager says to you, hey, can you show me each person's total sale? But also tell me what their sales were compared to the average for their region. If you try to do this with the basic aggregate functions like sum or average, you're going to hit a wall. And why is that? Is because aggregate collapse data into one single row. Like you can get the total sales per region or you can get the sales per person. But trying to show both side by side in the same query is painful. Usually you end up writing subqueries or joining queries back into themselves, which quickly becomes really messy and hard to read. And this is exactly the kind of problem that Windows functions were invented to solve. I know you want a definition, and I'm going to give a simple definition. In plain language, a Windows function is just a function that performs a calculation across a set of rows that are somehow related to your current role. Think of it like this. Each row gets to peek outside its own little bubble and see what's happening around it. Maybe all the rows in the same department or all the rows in the same time period, and then perform a calculation on that window of data while still keeping its own role intact. And to be very honest with you, that's why we call them Windows function. They didn't get the name from any other place. Each role essentially gets a little window view into the other data set. And a couple of reasons why Windows functions are very important, and I've said a lot of things about them when we started, but I'm just going to highlight four main reasons why you need to use Windows function. Number one is the fact that it gives clarity. Instead of writing messy subqueries, window functions let you express calculations in much more readable way. The second is the fact that it gives you flexibility. You can combine row level detail with aggregated insight in the same query. Number three is really about performance. In many cases, window functions are more efficient than writing multiple joins or subqueries. Number four is real world use cases. You will see them everywhere. Ranking top performing salespeople, calculating running totals over time, doing year over year comparisons, finding percentiles or medians in big data sets. You're going to see it everywhere. Enough of too much talking. Let's go a bit technical and try to break it down. I know you like going technical with some of these things. A Windows function is written almost like you would write your normal aggregation function, but with one extra keyword, and that word is the over. That over keyword tells SQL, don't collapse the rows. Instead, calculate this function across a sliding window of rows. What that helps you to do is that you're able to control what that window looks like with things like partition. When you use partition by, you are able to group rows into categories like department or regions or just any kind of category you want to use. And you also use the order by. The order by helps you to define a sequence like dates or scores and even frame clauses which define how far the window stretches and how far you are able to stretch that particular window function to be able to look through your rows of data. Don't worry so much about this because we'll see all of these shortly when we get into the examples. For now, just remember the keyword over because over is the magic ingredient that turns a normal aggregate into a Windows function. All right, let's set up the stage. I'm here in my BigQuery workspace. And if you've not, please go ahead and create your project and you can simply create your project here. I've done mine already and I have a couple of data sets that I've created. This is the dataset I'm going to be using for this particular demo, and I have it here already created. And I have the script which we are going to use, and I'm just going to explain that quickly. We'll be building a table that we will use for our Windows function demos. We have the ID. The ID column is unique ID for each of the sales, and this is really a sales data set that we're just going to use to iterate over and look at everything that has to do with the Windows function. We have the salesperson. The salesperson is the name of the salesperson, obviously, and is a string. We have the region, which is a string as well. It just tells us which region they belong to. We have the sale date, and the sale date tries to tell us when the sale happened. And the final one is the amount. The amount essentially is about how much the sale was worth at the time of sale. And we have these dummy data that we want to insert, and we are going to be inserting into the table that we are going to create and insert all of this. So you choose whatever you want to insert into yours, and these are just my own random value that I'm going to be inserting into this table. This table will give us enough variety to play with. It has multiple sales per person, it has different region, it has different dates and amount, and I feel my data set is just enough for me to do this. And when I run this, it's going to create this table. I'm going to do that quickly. And this tells me that it's been created. And please ensure that when you are doing this, you are using the name of your dataset as the schema to create your table here. And when I come down to this place, I'm going to see that my sales table has been created. And you can always quickly confirm that by just coming down here. I can do a select all. And if I run select all on this, it just gives me my table. I can see my table created here. So with this, we're going to go to the fun part. And the fun part is we're going to start to running real queries with BigQuery. So this is just a basic Windows function. We're going to be checking global average. Each row keeps its own amount, but also shows the average of all sales in the dataset. Essentially, I'm selecting the ID, salesperson, and the amount, and I'm going to be taking average. Typically, if you were to write this the normal way, you're going to say take average, and after that, you come back to do a group by, and it's just going to aggregate across the categories. But this is not going to do any aggregation. It's going to give me the average, yes, but it's going to use this keyword. Remember when I told you about this keyword called the over? It's going to use the keyword and give us the average, still maintaining all of the row level details that I need and that I have already. And it's just going to add an additional column, call it the average sale. So let me run this, and when I run this, you can see it's giving me the average of all of the amounts, and these are all the averages. It essentially added a new column and gave all of the averages without doing an aggregation, which is very brilliant because there are different use cases where this is very important. Now, the next one is ranking and row numbering. You rank sales within each region by amount. Let's say your manager asks you, who is the top salesperson in each region, and ask you to give him a ranking. And that is a perfect use case for this because you have the row number. The row number is the critical part of the whole ranking. The row number just assigns unique numbers even if the amounts are tied. Let me run this. I think it's going to be very useful to explain it better when you are seeing the output. Yeah. So remember here, I selected 3 columns, 1, 2, 3, and these are the additional columns that I added from my script here. And I'm going to explain. So look at the row number. The row number is partitioning by region. Partition is trying to say, put this in categories based on the region. And when you come to this place, you can see this is the critical column, the region column. It started with the east, considered everything in south, then before considering everything in the north. It looks at the east and asks itself, is there any amount attached to the east? And we have 1 that is 900. It gives it a row number of 1. It looks, is there any other east? There's no other east in my data set. Then it goes to the next, which is south. It comes to the south and say, how many south do we have? We have 3 rows having south because we are partitioning by the region. And we are ordering by amount in descending order. So what it does is it says, I want to take south, and I'm going to take the largest number because we are ordering by amount in descending order. It takes the largest amount, south's largest amount, comes next, takes another south, the second largest amount, 700. It takes the last cell and takes the least amount, which is 600. And it gives it the row number 1, 2, 3. Then he asks, is there any other south? There's no other south. It comes to north. In the north, it takes all of the combinations of the region and the amount and gives them row number. Each of these will have a unique row number 1, 2, 3, 4, 5, 6 because you are partitioning by the region. If we were partitioning by the salesperson, it's going to be a different ball game. It's going to compare the salesperson with the amount or whichever column we want to use in ordering. That is for row number. It just assigns the same amount. And in this situation, I have the same values in my amount. The row number doesn't care. It just assigns a unique one for every combination. And if there's a repetition, it goes ahead and assigns a unique number to them. But it's a different ball game when you come to ranks. If you observe, here you have unique number 2, unique number 3. The rank assigns the same number to them, essentially trying to tell you that it's a repetition. However, the rank skips 3 and assigns 4. So what you have is if there's a duplication of any sort, it just skips it and assigns the number 4, and you don't see 3. Unlike what you will have with the dense rank. The dense rank doesn't skip it. Any tie gets the same rank, then the next number continues normally. So you have 2, 2, and it goes on to give 3 and 4 and 5. Okay, let's look at partitioning as the third one. In partitioning, we're going to compare each salesperson's sale to the average in their region. Now let's revisit our earlier classroom analogy. Suppose we want to know how does each salesperson's sale compare to the average in their region. Again, I'm going to run this so it's going to be easy for me to explain it. Now, what am I doing? I'm selecting 3 columns: salesperson, region, and amount. If I just take the general average, like the initial example we had, the first example, it's just going to give me all of the averages on this place. But what we are doing is, instead of saying, give me the general average, we want to say partition by region. Essentially, we're saying, give me the average for each of the regions. For example, when you come to South, it gives me the average for all of the amount in South, in the Southern region. It goes to the Northern region, it gives me all of the average for the Northern region. And finally, it comes to give me the average for the Eastern region, which is just the 900. So you are able to use this. If it's a product, if it's a brand, you want to get the averages for each of the brand, you can simply partition by that brand and you're able to get the averages. And this gives you like averages based on the partitioning you want to do across your rows. So it's useful because you see here, you see the salesperson Charlie. Charlie's averages can now be considered only for his region. And you have Alice. Alice's sales can now be considered only for her region. And you're able to look at this across board. And you can do that segmentation because of the partitioning that you've added to the data. So now it's getting a little bit messy, and not messy in the sense that I'm using subqueries, it's just because it's getting a bit more complicated, especially if you are just starting out using SQL. We're going to be doing running total, cumulative sum of sales per salesperson over time. Imagine your manager says to you, show me how much each salesperson's sales add up over time, like a running total, and you're able to see how the total gets compiled and how they are moving. I'm selecting 3 columns, just like I've been doing, but now I'm using the sales date. I'm getting the salesperson's sales date and the amount. As usual, I'm going to run this so it becomes easy to explain. I'll explain the output, then we go back to the code to explain how the code works. These are my 3 columns. I don't need to do any explanation here. This is where I need to do an explanation. This is called the running total. The running total starts with the first amount. It gives you the amount and it does like a diagonal addition. It adds this to this. So you have the first 500, which is the amount here. The first running total is going to be that. And the next is 500 plus 200 gives you 700. 700 plus 700 gives you 1400. I can combine this now because of the partitioning I'm doing. I'm partitioning by salesperson. and the salesperson ends in Alice. By the time it gets to Alice, it gives me everything for Alice and it starts again for Bob. The 300 comes here, and when I'm done with the list for Bob, it goes to Charlie. So this is what happens. I'm taking the sum of all amount over partition by salesperson. Typically, we've been partitioning by region. Now we want to see each salesperson total over time. Partition by salesperson, order by sales date. As expected when you're using SQL, if you don't put any ordering pattern like descending or ascending, the default is ascending, and that's why starting from the earlier date going down to the later date. Rows between unbounded preceding and current row is very important because this defines the frame. Here, what it means is that it's trying to tell the code to start at the very first row for that salesperson and keep adding up until the current row. It's just trying to tell you keep adding up, don't stop. And if you do this first row, go to the second. When you get to the second, add this and go to the third. And is do all of this until you exhaust the list for Alice. And if Alice has about 100 rows of data, it's going to keep going and go back, just keep iterating until it completes all of the 100 rows of data. You're going to understand the difference shortly when we get to the next example. Okay, in this example, we're going to be looking at moving averages. We're going to be looking at the average of the current and the last two sales for each salesperson. Let me run this and just do an explanation on that. And this is on the assumption that your manager tells you that give me the 3 sale moving average. We'll just need to change the frame. Now it's not going to be an unbounded preceding. We're going to restrict it to 2 because we want to look at average of the current, and the current is any row that we are dealing with at the time, and the last 2 sales for each of those salesperson. Let's imagine that this is the place where we are. What we are saying is that consider this row and the last 2 row that was coming before it, that is the preceding. And that is what this means. The preceding and current. If it was unbounded, there's no limit to how far we can go. If this was one preceding, it means that when we come to this third row, for instance, it doesn't calculate the average. It doesn't consider this in its average. It's just going to consider these 2 in the average. And let me change this to 1 and do an explanation on that. If I should run this, you will see that the value has changed. Right now, when I come to this on this third row, the consideration for getting this moving average is just the current row and 1 preceding, which is the average of 400 and 500, which is 450. And it goes like that. But here, I'll just change it back to 2 because I'm doing 2 preceding and current. So it considers the 3 rows of data. Same here, it considers the 3. Here, it considers the 3. David has only just 1 row, and that stays that way. Well, I hope you found that very interesting. And thank you for staying up to this time. And when you go back to your query, I hope you're able to apply Windows function to make all of those messy queries you have and subqueries to become more cleaner next time you try to write your SQL. Please like and subscribe and show your boy some love. And also to encourage more people to see useful content like this. And I know I'm going to see you in the next one. Bye for now.